All right, let's continue on with our lesson 1.2. There's so many different examples and so many different ways to ask questions for this lesson, and that's why we've split things up into two lessons. Before we get started with a new set of types of questions we can face, let's first recap what our primary trig ratios are as well as our Pythagorean theorem, because we will need both for every question here that we do today. So just a quick recap that sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent, right? SOHCAHTOA. Pythagorean theorem, of course, is c squared equals a squared plus b squared. We are going to need that formula as well for this lesson to finish things off. So keep that in the back of your mind as we go through some of these questions. All right, so now, in general, for point P, which is the coordinate xy on the terminal arm, of an angle theta in standard position, we are going to find the ratios, but not with the words opposite and hypotenuse and adjacent. We're going to actually use x, y, and another letter r, all right? Because we are going to draw our unit circle again here and say that based on the terminal arm, or based on the point that's given here, x and y, okay, we can actually determine the angle here if we were to draw this radius of the circle, let's call it r as our radius. We can actually figure out the angle if we're given this coordinate, because if we're given this coordinate, what we're really given is this right here. This is our y value, okay? This is our x value. So if we're given this coordinate, we're actually given this distance in our right angle triangle. We're given from here to here for x and from here to here for y. From that information, we're able to figure out the angle there, all right? And we can potentially even figure out the radius of the given circle. Okay, so now instead of using words opposite, adjacent, hypotenuse, I'm going to use the letters for sine theta, if this is my angle of reference, theta. Opposite is my y, over, instead of hypotenuse, I'm going to use the letter r. So this is a new way to state the primary trig ratios without the words that we're familiar with of adjacent, opposite, and hypotenuse. So now I'm going to be now saying that sine theta is actually equal, on this Cartesian plane with a unit circle, is actually equal to y over r. Okay, and that actually makes more sense in these examples, okay, because we are dealing with x and y axes, so why not use x, y, and then r being the radius of the circle, which is our hypotenuse. Cos theta is x over r, which is, of course, again, adjacent over hypotenuse. Okay, that's our adjacent, that's our hypotenuse. Tan theta is opposite, which is y, over adjacent, which is x. Okay, opposite y over adjacent x. So please remember these formulas. Sine theta, y over r, cos theta, x over r, tan theta, y over x. Before we get to any sort of summarizing, let's do an example now. So we're going to use these formulas in a way that we're going to answer a question that is going to require us to use these formulas. So let's go down. Let's take a look. It says the coordinates of a point on the terminal arm of an angle theta are given. Determine the exact primary trig ratios for theta, meaning sine, cos, and tan. We have to write out the ratios, and there can be no decimals because it says to use exact values. Okay, no problem. Let's think about this here. Let's plot where this is. -9, let's call that -9, and 2. Here's where my point lies on the circle. okay? Call that negative 9 and 2. So I know that this distance here is 2, and that distance here is negative 9, okay? Because this coordinate is negative 9, comma 2. So it's negative 9 in the x direction, 2 in the y direction. I have to figure out the exact trig ratios. So I need to figure out what sine theta equal to y over r. I need to figure out that ratio. I need to figure out cos theta equals x over r. And I need to figure out tan theta equals y over x. I have to figure out those ratios to answer this question and just write them out. That's all. Well, I know x is negative 9. I know y is 2. So I can actually start to fill all of these in because I know x and y. I know y is 2, but I don't know r yet, right? I clearly do not know r, the radius of this circle. Cos theta equals x over r. Well, I know x is negative 9. I just don't know r yet, so I'm just going to leave it. And then y over x I can actually figure out. It's 2 over negative 9, but you don't write the negative in the denominator. It's more proper to just write the negative in the numerator, okay, or in front of the fraction, either one. It means the same thing. So I almost finished this, right? I know my tan ratio. I don't know my cos ratio fully, and I don't know my sine ratio fully. I need to find r in order to do that. How can I find r, the radius of that circle? Well, if we created a right angle triangle here, we can find r using Pythagorean Theorem. Except instead of using c squared equals a squared plus b squared, I'm going to use r squared, which is my hypotenuse, is equal to x squared plus y squared. And I'm going to solve for r. X squared is negative 9 plus 2 squared. It's 81 plus 4. Okay, 81 plus 4, which is 85. Take the square root of 85. Now remember, we have to keep these in exact values. That means no decimals. The square root of 85, just leave it as the square root of 85. So now when I go into here, I can square root 85. I can write in my r value as being the square root of 85. And so this is my final answer. Simply just writing out the three ratios. That's what the question asked for. Write out the exact primary trig ratios for theta. Let's do the same thing here. We're given x and y. Okay, let's plot this point. We're at 5, negative 11, somewhere down here. Here's where my circle is, right? So again, I don't know r, but I do know my y value is negative 11, and I do know that my x value, or here, is positive 5. I have another right angle triangle, so I can solve for r. Because I know I'm going to need r, I have to write out the three ratios. So sine theta equals y over r. Well, all I know is y right now. It's negative 11 over whatever r will be. Cos theta equals x over r, which is 5 over whatever r will be. And then I actually know all of tan theta as being, oops, sorry about that, y over x, which is negative 11 over 5. So I actually know that full ratio. But let's find r now, our hypotenuse. Okay? And you get r squared equals 146. The square root, leave it as the square root of 146. And so now you come here and you write you write square root of 146 as our r. Okay? Now, it's not proper for us to leave a square root in the denominator. I'm not overly too worried about it right now. I want us to learn this, and then maybe in our next lesson, I'll show you how to deal with that. But you'll find that your answer's in the textbook. So some of the questions in the textbook won't have the exact same answer as you, especially only when you have a square root in your denominator. They are going to not have that. They're going to convert it. So we'll take a look at that in another day or so on how to do that. But as of now, let's stick with this. You're learning enough new things right now where we don't need to add anything else to it. All right, so next question. One of the primary trig ratios for an angle and its location is given. Determine the other two primary trig ratios and give exact answers. So we're given a trig ratio, the cos trig ratio. We have to find the other two. So in our case, we're going to find the sine of A and we're going to find the tan of A. And notice they use the letter A, so I'm using the letter A. All right, they've told me that it's in quadrant 2. So they were specific as to which quadrant, because I know from our previous lesson that this ratio could exist in 2 different quadrants with this exact value of -3/5, all right, or -0.6. So, but they've told me that it's specifically right here in quadrant 2, okay? Try to draw a better straight line. It's here in quadrant 2. And so, okay, so let's look here. What have they given me? They have given me if cos of A is equal to x over r, and it's equal to -3/5, that means I know that x must be -3 and r must be 5. Now you might ask, well, how do you know, because the negative is in front of the fraction, how do you know what's negative, the 3 or the 5? Well, remember that r always has to be positive, right? R is always positive. Okay, so in our case, then it must be the 3 that's negative. So here we know that this must be -3, our x value. Okay, the question is, this is -3. The question is, what is the y value right there? We don't know what that y value is. If we're going to write out the other ratios of y over r and y over x, we clearly need to know what y is. Okay, but we know the radius and we know x. So if we set up Pythagorean Theorem, okay, if we set up Pythagorean Theorem and we sub in our 5 for r, and we sub in our -3 for x, we can solve for y. Okay, do 25 minus 9, bring the 9 over, leave y squared there. You end up with 16 equals y squared. Take the square root. Now we know that it can be the plus or minus square root of 16, meaning that -4 squared would equal 16, but also +4 squared will equal 16. But because we know we're in quadrant 2, this must be, okay, because we're in quadrant 2, this has to be the number 4, +4. Okay, because we're in quadrant 2, that has to be 4. So the coordinate here must be -3, 4. Clearly, because we're in the positive y direction here. So it's not negative. So if you were to write plus or minus 4, that wouldn't be the answer. The answer here is just simply 4, because we know we are in quadrant 2. If they didn't tell us we were in quadrant 2, then it could either be positive or -4. But because we know we're in quadrant 2, we know that it has to be a +4. Okay, tan Oh, and now let's actually answer the question, of course. We had to write out the ratios. Okay, so let's write out sine of A is equal to y over r, which is 4 over 5. And tan of A is equal to y over x, which is 4 over negative 3. So let's write the negative in the numerator, okay? And let's do that, all right? Or write it just in front of the fraction, okay? Either way works. We just typically in math, we don't show the negative in the denominator. We show it in the numerator or out in front of the fraction. Okay, let's practice this again. Tan b equals 8 over 3. So what have they given us? Well, they've given us, since tan theta is y over x, that means they've given us y and x. So y equals 8, x equals 3. And if we were to draw this out, we're in quadrant 3. This would be, something weird is happening here. If we're in quadrant 3, how could we have a positive 3 here and a positive 8? It must be that they were both actually negative, because negative 8 over negative 3 would equal 8 over 3. Do you see how there's no way we can be in quadrant 3 and have a positive 3 for x and a positive 8 for y? It's impossible. They would have to both be negatives. And then when you do put them into your ratio, they end up being positive because you're doing two negatives divided by each other. But we know that the actual answer here is that x is actually negative 3 and y is actually negative 8. So be careful there. Okay, that makes a big difference. So we have to find the other two ratios, and to do that, I mean, if we're setting up sine of b, it's equal to y over r. Cos of b is equal to x over r. Well, I know y, but I don't know r. And I know x, but I don't know r. But I can find r. Okay, make sure you sub them in and simply solve for r. Okay, so you end up getting negative 3 squared is 9 plus 64. Okay, so you end up with the square root of 73. So you come down here and you do square root of 73, square root of 73. Here is your answer, finding the other two ratios. We were already given this ratio. We had to find the other two, and there they were. All we did was solve for r, and we also recognize that it's negative 8 and negative 3 because we're in quadrant 3. Okay, let's look at our last two types of questions here. It says, determine the exact primary trig ratios for each angle. Okay, exact primary trig ratios. So no decimals, and we have to find all three ratios. Okay, so we have to find, I'll draw it to the side here, sine of angle A is equal to y over r, cos of angle A is equal to x over r, tan of angle A is equal to y over x. So we have to write out these three ratios, but all we're given is an angle. So, I mean, inevitably when you get this, let's draw the sketch. Let's see which quadrant we're in. Let's see what's going on here. So, not that we necessarily need this right now, but let's write out our cast letters there. We're in the second quadrant, 120. Okay? How are we going to figure out x, y, and r for this terminal arm? Well, let's find the related acute angle. If this is 120, that means this must be 60. All right, 120 plus 60 will equal 180. So we found the related acute angle there. Okay, then bells should be going off in your head saying, oh, this is a special triangle. Across from the 60-degree angle is our square root 3. Our hypotenuse is 2. And across from the 30-degree angle is our 1. But because we're on the negative x-axis, we're actually at negative 1 here. So it's negative 1 from here to here. Okay? And there you have it. We have our x, y, and r, right? We've got x is equal to negative 1, y is equal to the square root of 3, and r is equal to 2. Now you just sub in all your values into your ratios, and you get square root of 3 over 2, okay, negative 1 over 2, and the square root of 3 over negative 1, which is just negative square root 3. Okay, there's your final answer. We wrote out all three ratios, and the way we did that was we drew a sketch of the 120 principal angle. We realized, what happens if we find the related acute angle? We need to know the x, y, and r here of this point, okay? We found that the related acute angle was a special angle of 60 degrees, which means that we knew the sides of our right-angled triangle. And then from there, we simply wrote out what our x was, our y, and our r, and subbed them into our ratios. Let's try it one last time, okay? So again, I'm going to write out that sine b is equal to y over r, cos b is equal to x over r, tan b is equal to y over x. Okay, let's draw a sketch, see what's going on, what quadrant we're in. We are 315, which means we're going all the way to the fourth quadrant. Okay. If this is 315, what is my related acute angle? 45 degrees, and that is a special triangle. So I know what the values are and what the coordinates of this point will be, because I know that across from my 45 is my 1, but because we're in the negative y direction, it's actually negative 1. And then here on my x direction we're on the positive x-axis, so it's just positive 1. My radius, my hypotenuse, is the square root of 2. That's my 45-degree angle triangle. The only difference is that number is negative 1 because we are in the negative y-axis. So we get negative 1 over square root of 2. Okay? 1 over square root of 2. And then y over x, negative 1 over 1, which is negative 1. Okay, and there you have it. There is a different set of questions there. Now, in class, I'll be going over even more examples than this. All right, so this is one of the lessons. It's 2 big parts where you really, really have to bear down and just practice, practice, practice until you get the hang of what to do for each type of question. Okay, and like I said, I'm going to go over a couple more examples in class because there are some things that I didn't touch upon here that I will touch upon. And then I will also show you how to handle when you have a square root in the denominator. I'll show you in class how to take care of that so that you no longer show the square root, so you can create an equivalent fraction without the square root in the denominator. Okay, and this way, so when you check your answers in the back, they'll actually match up, because currently they will not.